Hello, welcome to a presentation on the SAS data connectors using the SAS Enterprise guide. So this is presented by Rahul Yadav, Apoorv, Chaturvedi, and Mr. Rabinder Singh. So this is our experience has been under the whole domain, but starting with data capturing, data cleansing, transformation. We intend to stick only with the ETL and the ELT processes for our work. We actually started our operations about 3 years ago, and our initial sales approach was we used to do direct reporting over ERPs. So we would write custom SQL and do direct reporting over ERPs, and the business logic was actually coded at the reporting and the semantic layer. So we were not actually doing normalization and doing the reporting, but it was done. Our reporting layer was highly denormalized, and we used to use heavy use of custom SQL coding for business logic. Our problems started happening immediately. First of all our POCs took a lot of time. It took between 2 and 4 weeks, and each of our POCs used to cost us more than 40,000 each. Our implementation time was also very high, since we would start with the base and we would do the custom SQL coding starting from the scratch. Therefore, the cost and the time for implementation was very high, at least 4.5 lakhs per implementation. When we went into projects, inevitably the clients would expect us to consolidate data from different type of sources. So that was required, and the clients were also expecting that the data be integrated on a real-time basis. And we also had the auditing requirements from the client as well as capturing the history. The problems came that first of all was that the client wanted also to capture the on-fly calculations at the database level, and for maintaining the business logic at the reporting level, because we were coding it using custom SQL, it was very complex, and specifically over a large number of reports, it became really complicated for us. Our system was not plug and play. It was not a product. It was not on a large layer, and the reporting layer was highly denormalized. So we had multiple cubes. Maintenance and ease of use was an issue. Also, we discovered that the customer expectations were as following. The customers are highly value conscious. I mean, the Indian customers in India are very much aware of the best practices and tools across the world, and they also look for total attractive cost of ownership. Also, we found that the customers are looking for a net solution. That means their inclination to pay for services is low. So they look for a complete product solution. And for us, the sales challenges were that we had to show the value quickly to the end client. So, I mean, how do you do analysis over time, analysis across buyers, analysis across complementary products and services, and analysis across functional and emotional appeal to the buyers. And the problem was how to show the information in an easy to understand and intuitive fashion. So primarily what we feel is that the analytics is for what-if analysis, for making dashboards, and for forecasting. Primarily for making dashboards and for forecasting and what-if analysis. So for the challenge we faced was how to show the value of analytics for forecasting and what-if analysis over unstructured data sets. So our solution was to crash the POC and the implementation times and make the reporting solution over only a static data warehouse. And the data warehouse should be in a third normal form. So basically over the data warehouse, then you make the star schemas or the lab cubes. And our business logic should be coded between the staging layer and the data warehouse. So this is what is the conventional approach. So you have for each of these ERPs, you have a reporting layer. But our suggested approach is slightly different. We make a single data warehouse, and we have the reporting module and the mobile apps. So primarily the person who's making the reporting is actually insulated from the source system. So our value proposition is, so what are we actually looking? So we are looking to eliminate long ETL times, right? Primarily through the SQL, and we are looking to eliminate the dependence on domain experts for reporting, because they'll get one standard star schema. So you don't need the domain experts. What we are looking to raise is the value proposition for the end client. And what we are creating are the ready-made ETL processes, and we're trying to make the reporting outputs as a product, right? And ready-made what-if scenarios are going to be ready. And what we are looking to reduce is the reporting complexity and the data warehouse implementation time. So now let's look at an optimization problem for retail and manufacturing inventory analysis. So we look at analysis of gross profit by category for the last fiscal year. ABC categorization has actually been done as an ELT process in a data warehouse. So we find out the category A items with low gross profit, category A items with high gross profit, and other B and C category items. For A category items with high gross profit, we look at the gross margin, the percentage sales, and transaction contribution. We look at trend and seasonality, forecasting, then optimizing. So for this, we actually do the majority of the analysis. For category A items with low gross profit, actually, what we are looking to do is we are looking to actually siphon them out. So we set the benchmark for percentage sales, transaction contribution, gross margin, and then look at markdown, browsing, and supplier analytics. So retail inventory optimization. So now retail company has 12 branches with more than 300 products. The product manager needs real-time visibility over what products are important for the company, and end client wants to see the what if scenario and the forecasting for the inventory. So this is our first graph. So now if we look at this graph, the orange ones are the percentage sales and the yellow ones are the percentage gross profit. So here you see the gross profit is more than the percentage sale. The size of the circle was the cost of goods sold. The size of the circle in both the cases was actually the same. Now the case that comes is what is the distance between them. So now this is an optimum scenario. You're getting more gross profit with lesser amount of sales. It's a most satisfactory situation. Then you're getting the same amount of gross profit with the same amount of sale. But here what we are seeing here is that with this is the least satisfactory. That means the gross profit and the sales, they overlap. Now we look at the second one is now the blue circle. So the blue circle here. So here the size of the circle is the blue circle is the cost of goods sold, and the red is the gross margin. Now what is happening here is that with lesser sales, more gross profit is being generated, right? Percentage sales for category A. So this is a good situation. Now in category B, what has happened here is that your sales has increased, but your gross profit has come down, right? So your sales has gone up, in the blue circle has gone up, but the gross profit has come down in percentage of gross profit. So now this product manager has to look into this. Why is it happening? Now in case of category C, what is happening is that with a lot more sales, we're getting a good gross margin as well. So with this good gross margin, you're getting good sales. But the most important thing was that this red circle is not changing in size. So now the case was the product manager actually hasn't changed the gross margin across various product categories. Then now let's look at this one. Now this is actually category A. So they are drilled down to the category A, and we are now looking at it into this thing. So now we have the sales value percentage and the gross margin percentage. So let's put it this way. The size of the blue bubble shows the cost of goods sold, and the red bubble shows the percentage purchase. So effectively the size of these two should be the same if the situation is normal. Now what we need to look at is what is the distance between these two. So if you look at it, now for a situation to be perfect, then this thing. Now the blue bubble, actually, if we go from bottom to top, the size of the blue bubble should increase. That means basically your percentage sales should increase. And in the case of the red bubble, what will happen is, see, suppose we're going from top to bottom. So your in the case of the red bubble, actually when we go from the top to the bottom, the size should increase, right? So that is how it takes place. So now in this particular case, what we are seeing is that the sales value percentage has increased incrementally, but you look at the gross margin. That means with a lower gross margin sales, you're actually having lower sales. But in this case, you're having higher gross margin and you're having higher sales, right? So this particular item needs investigation, according to us. And this was the most satisfactory situation. Then we next come down to this particular scenario. So now in this case, in case the red bubble and the blue bubble are of a different sizes, then it needs this thing. Now suppose the red bubble is bigger than the blue bubble, like in this case, then you could have an indicator of an inventory uh, problem. Now, in case the blue bubble is bigger than the red bubble, right, then that means that it is actually the prior inventory is being sold. Now you see, like in this particular case, the red bubble is bigger than the blue bubble, so this is actually indicating that there's an inventory problem, right? Now we next come down to looking at the category A items, but in a different format. And here we see that whatever sale you have, that much is the profit. So if these bubbles are close to each other, then you are okay, right? Now, in case the blue bubble is over the red bubble, then it means low profitability. In case the red bubble is over the blue bubble, then it indicates a high profitability, right? And the same case here. So here, this item needs investigation. That means with higher sales value, why is the gross profit percentage sales lower, right? Then now let's look at this particular case. Now, vice versa. Now which items need to be promoted? Now here you see in category B, this thing, which items is, so wherever the red bubble is over the blue bubble, then those items should be promoted. That's what we believe. And if they are close to each other, then the situation is normal. Now if you look at this category C wise item, now here you see that in this particular case, what's happening is the prior inventory has been removed because the blue bubble size is way over the red bubble size. That means the cost of goods sold is way over the percentage purchase. That means the prior inventory has been removed here. And where the red bubble is over the blue bubble, those are the profitable items. So conclusion, this is a category A is highly profitable. We got to know which items are of concern, and this is for the manufacturing industry. Thank you so much for your time.